says calculate the energy required to heat 0.6 kilograms of water from 24.8 degrees C to 48.8 degrees C. Assume the specific heat capacity of water under these conditions is 4.18 joules per gram to K. Round your answer to 2 sig figs. So basically, in a previous video attached to this playlist, I go through this equation in a lot of detail, but here I'm just going to give it again. Q, heat, equals M, the mass in grams, times C sub S, the specific heat capacity, times delta T, the change in temperature, where delta T equals TF, the final temperature, minus TI, the initial temperature. In this case, the final temperature is 48.8 degrees C, minus the initial temperature, which is 24.8 degrees C. So delta T in this case is 24.0 degrees C. So this is the change in temperature. Now Q equals the mass in grams. So we have to convert this 0.6 kilograms to grams by multiplying it by 1,000. So in this case it's 600 grams, and I'm just going to put a line under that to remember that that's the sig fig, because this is two significant figures, so this is two significant figures, times C sub S, which is 4.18 joules per gram, K. And one thing we have to notice here when we go to delta T is, my delta T is in Celsius. However, as I explained in a previous video attached to this playlist, a change of 1 degree C and a change of 1 K are the same. So we can simply plug this in as 24.0 K. And if you accidentally wrote degree C here, it wouldn't technically be correct because the units wouldn't cancel out, but it wouldn't actually practically make a difference either. When we do this math, Q equals 60192 joules. However, we have 2 sig figs here, 3 here, and 3 here, so our answer should have 2 significant figures. In order to write this with 2 significant figures, we need to write it in scientific notation. So one way to put this answer is 6.0 times 10 to the 1, 2, 3, 4 joules. This is a possible answer. You could also convert this to kilojoules by dividing by 1,000. There it's a little bit trickier. Alex will accept 60 kilojoules, so 60,000 divided by 1,000 is 60, so 60 kilojoules, or you could probably write this as 6.0 times 10 to the 1 kilojoules, because this is clearly 2 significant figures, although Alex accepts this as well. So sig figs are a little bit tricky here because that last digit is a 0, but this is the basic idea to solve this problem.